Originally founded in 1998 and later reorganized under its own holding company, Alphabet Inc., Google is easily among the most recognizable companies of the information age, and one of the most influential actors in shaping the World Wide Web and modern computing technology. Google maintains the Android operating system, otherwise known as the Android Open Source Project. It is the most widely utilized OS for mobile devices in the world. With over 3 billion active monthly users, it is of critical importance that security vulnerabilities in the Android OS be addressed by developers in an efficient, timely, and effective manner. To this end, the Android Platform Security and Assurance Team works to address concerns and notify the many original equipment manufacturers who utilize the Android OS of security vulnerabilities through the Android Security Bulletin. This information, combined with the information in the National Vulnerability Database, helps developers to address security vulnerabilities through security patches. The goal of this project is to provide OEMs first-party service to help them obtain and analyze the data from the Android security bulletins and the NVD in one place, combining the two datasets and serving pertinent information to users. This project aims to create an interactive database of Android security vulnerabilities along with an API and a user-friendly interface.
Hello, I'm Brendan, head of cybersecurity at Samsung.
And I'm Trey, a senior security engineer at Samsung.
We manufacture mobile devices that use Google's Android operating system. And as the most widely used mobile operating system in the world, it's critical both to our users and those of other companies that we address security concerns for our Android devices quickly and efficiently.
It can be hard for us in the cybersecurity community to keep up with malicious actors. For every improvement we make, hackers always manage to find new ways to exploit our software. It can be difficult to keep up, especially when we must split our focus between implementing fixes and doing research.
One resource we use to keep up to date is the Android Security Bulletin that is published monthly by Google. Google, as one of the most important tech companies of the information age and the entity behind the Android operating system, is interested in ensuring that customers can use their Android devices without exposing themselves to bad actors. The Android Security Bulletin helps communicate known security concerns with original equipment manufacturers.
Another resource we use is the National Vulnerability Database, or NVD, which is maintained by the United States federal government. It contains more extensive information on software vulnerabilities. The vulnerabilities in the Android Security Bulletin correspond to vulnerability records in the NVD. The problem is, it can be difficult to match up the information in the Android Security Bulletin with the records in the National Vulnerability Database, as there is no built-in way to extract that information.
That is where our secret weapon comes in, the Android Vulnerabilities Database, or AVD. The AVD takes the data from the Android Security Bulletin and National Vulnerability Database and does the heavy lifting of matching that data up and provides it to us via an easy-to-use API and corresponding web application.
With the work of compiling all that information done for us, it makes it easier to research vulnerabilities and strategize our development cycles. Oh, I just got an email from my boss. Let me see what the email says. Hello, Trey. Currently, our software runs on a patch level of 2020-0101, and we want to upgrade our software so that it runs on the patch level of 2020-0401. I need you to send me a list of all the vulnerabilities that need to be patched. Please report back to me by the end of the day. Thank you, Brendan. As my boss's email stated, I need to find all the vulnerabilities that need to be patched. Luckily, I know of a website that can easily accomplish this task. Let me head over to the Android Vulnerability Database website. From the homepage, I can navigate to the Vulnerability section that will bring me to a custom query page where I can parameterize my search results. From here, I want to get all of the Android OS security vulnerabilities, so I will click on the Android OS option under Bulletin Types. My search does not depend on base score, exploitability score, impact score, or component, so I can skip those. Next, I can then select the start and end date based on the patch level our software is currently on and the patch level that we want to upgrade our software to. I also need to select the patch level type. Since the patch level the software is currently on and the patch level we want to upgrade to is 01, I can select that option. The last option I will select is to order the result by sending date. Once I click Submit, I am brought to a page that shows 3 graphs giving more insight about the vulnerabilities that were just queried. Below those graphs are all the vulnerabilities that need to be patched to fully upgrade our software's patch level from 2020-0101 to 2020-0401. Now that I have all of the vulnerabilities at one place, I will write all the CVE numbers in an email that need to be patched and also some extra insights about the vulnerabilities that need to be patched and send it over to my boss.
Hello, I'm Dan, a junior security engineer at Samsung. To keep on top of new security concerns, my team would like to know if there have been any new vulnerabilities that have been introduced since the last patch, and I've been assigned to look into it. I'm going to use the Android Vulnerabilities database. The dashboard displays information on the most recently added vulnerabilities, so I'll start there. The dashboard shows an overview of the most recently added vulnerabilities and has a table below with more information on those vulnerabilities. This is useful information, but some vulnerabilities are more severe than others, and I want to focus on those. So I'm going to need something a bit more refined. I'll go ahead and click on the vulnerabilities page. I want the most critical security concerns at our patch level, so I'll look for the vulnerabilities with a CVSS base score of 9 or higher so that we can prioritize fixing those ones. What's a CVSS base score, you ask? Great question. The CVSS base score is a metric for any given vulnerability in the National Vulnerability Database, which has been analyzed. The score is calculated based on several variables, such as attack complexity, attack vector, and the impact on the system. But the important part is that the higher the base score is, the greater the risk that the corresponding vulnerability is to our users. I'll start by setting a minimum score of 9 and a max score of 10, so that I only get the most critical vulnerabilities and can filter out the ones below that. This will allow me to determine what security concerns my team and I should focus on for our upcoming patch. Then I'll select my date range. At last, I'll select the patch level. Then I'll hit search. I'll be taken to a new dashboard. At the top is the overview of all the vulnerabilities that meet our search criteria. Below, I have a snapshot of each vulnerability that met my search criteria, and I can click on a card for more information. Now I know the highest priority vulnerabilities to focus on for the upcoming patch level. I can take this information to my team and we can formulate an implementation plan.
My name is Alex, and I am a security researcher for threats facing the Android security platform. Android, being the world's most popular mobile operating system, is a prime target for attackers. A robust vulnerability database is a critical tool for researchers to stay ahead of these threats. As a security researcher, staying ahead of these threats in the Android ecosystem is crucial. That's why I rely on the Android Vulnerability Database. One of the core features of the Android Vulnerability Database is searching by CVE number. Whenever a new CVE surfaces like CVE 2023-4863 mentioned in the latest Android Security Bulletin, I turn to this database for insights. By putting the CVE number into a search bar, I can quickly access detailed information about the vulnerability. I can even browse Reddit for associated press releases, gathering more context about the vulnerability. I see as I enter CVE 2023-4863 here into the Reddit search feature, I see that a post made on r/Android was posted 7 months ago, detailing about the CVE. Within the database, I find the severity and the base score, crucial for understanding the potential impact of the vulnerability. I regularly check the homepage to see trending vulnerabilities, ensuring that I stay informed about the latest threats. With Google Analytics tracking views and insights, I gain valuable intelligence about which vulnerabilities are receiving the most attention. Armed with these insights, I can make informed decisions to protect the Android users from emerging threats.
Let's talk about the technical specifications for the AVD. Extract, load, and transform processes are performed using Python. The associated scripts are run using a serverless architecture via Google Cloud Functions once per month. The execution of these scripts is handled via Google Cloud Scheduler. Data from the Android Security Bulletin is extracted using web scraping techniques, and data from the National Vulnerability Database is extracted via their first-party API. This raw data is then stored in a Google Cloud Storage bucket, and from there is uploaded to a cloud-hosted MySQL database and eventually merged into a complete dataset.
Our Angular front end is run on the Cloud App Engine, and our Flask API is run on Cloud Run on the Google Cloud Platform. The Angular front end uses the Flask API to interface with the database. Customers can interface with the Flask API on their own if they would like to use the data to create their own personalized dashboards.
We would like to thank our project sponsors for their support and the opportunity to work on the AVD project. We would also like to thank the course staff for the MSU CSE Capstone course for their efforts and guidance. And thank you for watching our project video.